I'll have the practical going on. But right at this moment, I don't have the server installed. So maybe I will take some time and try to demonstrate the server's installation also. It takes maybe one session for installation of server. Okay, we'll try to see that practical also. Surely, inshallah, we'll try to have those things. Okay, thank you for that comment. So we'll try to see what are the tools available practically when we are going to do with it. Very nice thing mentioned by Ravi Kishore. Now, how do we name the objects or the parts of the objects, and how do we refer to them? Whatever things are there in the database, they are considered to be relational. Relational in the sense they are to be considered in terms of tables. Though we are going to make them in terms of tables, but practically speaking, the database has been written nowadays, the Oracle has been written using the Java language, which is object oriented. So logically we are thinking that we are creating a table, but at the end moment when it is being saved into the hard disk and when it is practically being put it into a physical form, it is being saved in terms of objects, because you know Rdbms is not just the data, it is a set of software tools, components which are also helping us to interact with the data. So those softwares are actually object oriented. So how do we refer to objects, practically speaking? So to refer the objects, what we need to do is, first we need to understand in which schema that object belongs to. Schema can be a name defining the database. Schema can be a logical structure of your table. Schema can be logical structure of your sequence, can be of a view of something like that. So what is the logical structure name? You need to mention it first. Then with the dot operator, you need to mention which object in that particular logical schema you are talking about, that particular name. Then with the dot operator, you need to mention which part of the object you are trying to interact with. And if in case that particular object in the schema is present onto a different server, then you need to mention a @ symbol, and you need to mention the link for that particular database, the website link or that particular location link database is available. Okay, so this is the general syntax which we have tried to be very clear cut, and the same part has been written in the theoretical part. So you can refer back to those things. Okay, fine. So basically speaking, how do we represent a database object? How do we refer to a object part of a object? Simple. What is the schema name? With a dot, what is the object within the schema? With a dot, what is the part that you are trying to access within that particular object? And if in case, if the database is present onto a different server, with a @ symbol, you need to mention the link of the database. This thing has been kept in the statements here also. So what are the objects which are considered to be schema based, and what are those which are considered to be non-schema based? Remember, schema objects are categorized. Schema objects are categorized onto two different categories. One is those schema objects which share a common namespace. Namespace in the sense they will be sharing a common memory location. That memory will be given a specific name, so that if I refer to that particular memory, I will give a name, and that name will say, okay, so and so particular object is going to have the value in this particular memory space of so and so value. But the same name may be present in another memory location with a different value. So by categorizing the different memory locations, we can have for one single variable name multiple values. So that's a practical purpose of namespace. So what is the schema? Schema may represent the logical structure of any object in our database. Schema of a table will give the table name, a list of columns that are available along with the data types of the columns, and some constraints if they are there. Like for example, if there is a primary key to be mentioned, if there is a check constraint to be mentioned, if there are certain constraints, those constraints are also considered as schema. So basically, schema is a logical definition of a particular object. Clear? So in case of schema objects, we categorize those objects based on two categories. First category is one which shares a common namespace, another has its own namespace. The one which are going to share a common memory space has been listed over here. These objects are going to have their own schema definitions. For example, for a table, the schema definition will be the table name, the list of columns which are going to make up the table along with the data types, and if there are any constraints, those constraints also come as a schema definition. Views schema will define what is the name of the view, how many tables were used to generate that particular view, what are the columns that have been selected from the tables to generate that particular view, along with certain constraints if they are there. Sequences are for automatic number generations, for easy computations. Like for example, if I have to just imagine, if I have to remember the account number allocated, suppose if I am the bank manager and if I am had to allocate the account numbers by myself practically, then I had to remember what was the account number given to the first customer, then to the second customer, then on to the nth customer. Can I recollect what are the account numbers given? Can I memorize them and uh, give such a big number, 13 digits wide number to each and every customer? No, it becomes very difficult. So computer will help us to generate those sequential numbers, and we can allocate them without even remembering whether this number was used for some customer or not. Can it be used for a new customer or not? So those, in order to remove those doubts, in order to generate some numbers which can be associated to some objects, we'll be using sequences. Sequences is a schema object which will be used, and it shares a common namespace. All the numbers will be kept inside one single memory location. Like we have got nicknames at our home, we have got synonyms for objects. We can use the nicknames or synonyms for the objects, and we can call those objects. The synonyms are of two types, private and public. Private in the sense, these synonyms will be valid only for that particular user who has created the synonym, and public means they will be accessible throughout the world. So we have got various other things coming up, like for example, certain procedures and functions and packages, which are a combination of all the above, and materialized views and user-defined types. All this comes into a category called as schema, which shares a common namespace. Similarly, we have got another type of schema object which has its own namespace. That means it will not share its memory with another object. And these are indexes, constraints, clusters, database triggers, private database links, and dimensions. All of them you'll be able to understand once we finish our second unit and third unit. Okay. So indexes and constraints you can easily understand. To give a glimpse of about what is a cluster, a bunch of objects which are having some common characteristics is called as a cluster. They will be made into one single unit so that they can be referred easily. Okay, so for example, if I am talking about students clusters, I will group the students based on their performance. Let us say I don't want to distinguish based on the performance, but let us say for name's sake, I'm clustering them based on their performance. So I will create a category of cluster which has students with high performance, 80% and above. One new category will be there, which is composed of average performance, 70 to 60. Another one which are a little poor in subjective knowledge, and that will be 60 and below. So like that, I will try to create clusters so that they can be easily handled up. We have got database triggers which are background running programs, and these programs will come into picture only when a particular event happens. So database links are simple. Dimensions are going to talk about how many databases are going to be connected on. I think within 2 minutes the meeting is going to end up. So we'll be getting back into subject after 2 o'clock. Like schema objects, we have got non-schema objects, and these schema doesn't has its own memory space. Uh, they can have, but they don't require much memory as that is required for these objects. For example, user roles. These roles are single words. For example, the role between the loan and the person who is taking a loan taker. The Do you recollect the AR diagrams, entity and the relationship? There were some roles being mentioned on the lines that depicted what was the role that the entity was playing in that particular relationship. Faculty and a student, there was a relationship called as course, and faculty teaches course, student undertakes course. So teaches and undertakes. That particular roles are single words. They don't require much memory as that is required for schemas. Though they have their own namespace, but we generally say they don't require much memory. Synonyms, they are nicknames given for some particular activity. So these synonyms are also not going to be consuming much memory. Public database links. Do remember, wherever public is going to come up, they are considered as non-schema objects. Like table spaces, profiles of the users, parameter files, and server parameter files. All these things are little enhanced concepts, and you will be able to understand it in the later stage of your Rdbms, not now. I have just listed them so that you can just get a glimpse that they do exist. Is it clear? So referring of the objects, it's the same what we have discussed earlier, but here I have just added a domain to it. But if it is a remote one, you need to mention the domain. For example, Google @ the computer name, that particular part. It's not so typical. You just refer back to the previous slide which we have discussed. So what are the literals and text and integers, literals and constant values? Anything which has been kept in single quote, in Oracle, there are no double quotes. There is single quote. The string is composed of single quotes, not double quotes. So whatever you write in single quotes will become a character literal, will become a text literal. Okay. So we have got